Imagine looking up at the sky on a starry night, feeling the vastness of the universe around you. Each star shining high above reminds us of a deep mystery, what exists beyond what we can see. What lies in the depths of the cosmos that we still don't understand? Since the dawn of time, humanity has been fascinated by the universe. Our curiosity about what exists beyond our small planet leads us to ask big, often perplexing questions. How did it all begin? What is our place in all of this? And perhaps the biggest question of all, are we alone? Throughout the centuries, scientists, philosophers, and explorers of human thought have tried to answer these questions. They have looked to the sky and, over time, formulated theories, models, and concepts that gradually bring us closer to understanding the universe. But the more we learn, the more mysteries arise. Get ready, because we are about to embark on a journey through some of the most intriguing theories humanity has ever created about the universe. A journey that will take us from the moment time and space were born to the farthest reaches of realities we may never be able to touch. The universe is full of secrets, and we are about to explore them. Imagine that tiny point, a singularity of infinite density and temperature, where all the energy and matter that make up the universe were compressed. This moment, known as the Big Bang, wasn't just the beginning of space, it was the beginning of time itself. Before it, there was no before. Everything we know, from the most distant stars to our own bodies, was born there, around 13.8 billion years ago. But this explosion wasn't like the explosions we imagine. It wasn't something that expanded into space. It was space itself that began to expand. Like a balloon being inflated, the universe started to grow exponentially. In a fraction of a second, it went from something smaller than an atom to something the size of a galaxy. This initial moment, called cosmic inflation, was so rapid and intense that it shaped the structure of the universe we see today. After this inflation, the universe began to cool down, and that's when the first particles of matter appeared. First, quarks, the fundamental building blocks, formed protons and neutrons. As the universe continued to expand and cool, these protons and neutrons combined to form the first atoms, mainly hydrogen and helium. These atoms then clustered together, forming the first stars and galaxies. The Big Bang also left a visible scar on the cosmos. This scar is the cosmic microwave background radiation, a sort of leftover glow from the universe's creation, which permeates all of space. Discovered in the 1960s, this radiation is like a photograph of the universe in its infancy, a distant echo of the moment when everything began. But despite all these rich details, the Big Bang is still surrounded by mysteries. For example, what happened before it? Did the universe emerge from nothing? Or was there something beyond this singularity? These are questions scientists still struggle to answer, and this is where other intriguing theories come in. The Big Bang gives us a powerful idea of how the universe began, but it also reminds us how much we still have to discover. But the Big Bang was just the beginning of this story. Shortly after this initial explosion, the universe began to expand at an astonishing speed, and this is where the theory of inflation comes in. This theory suggests that, in the first moments after the Big Bang, the universe went through an incredibly rapid expansion, much faster than it is today. Imagine that in a fraction of a second, the universe expanded from a subatomic size to something the size of a galaxy. This dizzying expansion is what allowed the universe to become homogeneous and stable, explaining why it appears so smooth on a large scale, with galaxies evenly distributed without major disruptions. The theory of inflation also helps answer one of the most intriguing questions: why is the universe so flat? When we look at large scales, space doesn't seem to be curved, as we might expect due to the immense amount of matter and energy. Cosmic inflation stretched the universe like a sheet of paper, making it appear flat when observed from great distances. But there's something even more fascinating about this inflationary phase: it may have created multiple universes. While our universe expanded rapidly, other pockets of spacetime could have done the same, creating what we call the multiverse, a collection of parallel universes, each with its own laws of physics, its own histories. Could there be other versions of us living in different universes, with completely different realities? This is one of the most intriguing implications of inflation theory. However, even this fascinating idea isn't enough to answer all our questions. The expansion of the universe didn't stop. It continues to this day, and the most curious thing is that this expansion is accelerating. Something is pushing the universe, making it expand faster and faster, and the answer to this lies in the next great mystery: dark energy. Dark energy is undoubtedly one of the greatest enigmas of the modern universe. As scientists observed distant galaxies, they expected to see signs that the expansion of the universe was slowing down. After all, gravity should be pulling everything back. But, to everyone's surprise, the data showed the opposite. The universe is expanding faster than ever. This means that something invisible and mysterious is pushing galaxies away from each other, overcoming gravity. This something is what we call dark energy. It cannot be seen or measured directly, but we know it's there because the effects of its force are undeniable. It is estimated that around 68% of the entire universe is composed of this unknown energy. The question, of course, is, what exactly is dark energy? The truth is, no one knows. There are several theories. One suggests that dark energy is an inherent property of space itself. As the universe expands, it creates more space, and with it, more energy. It's as if the very fabric of the cosmos is generating a force that constantly stretches it. Another bolder theory proposes that dark energy may be a sign that our understanding of gravity is wrong on cosmic scales. Perhaps the laws that govern the movement of stars and planets work differently when applied to the universe as a whole. This would require a complete revolution in modern physics. What's most impressive is to think about the consequences of this eternal acceleration. If dark energy continues to push the universe at an ever-increasing pace, there will come a point where galaxies, stars, and even atoms will be torn apart by this expansion. This scenario, known as the Big Rip, is one possible tragic end for the universe, where everything would be shredded into nothingness. Dark energy leaves us with more questions than answers, but it also reminds us of how much we're only scratching the surface when it comes to understanding the cosmos. And while we try to decipher this enigma, there's another mystery that complements this story: dark matter. If dark energy is mysterious, dark matter is not far behind. While dark energy pushes the universe outward, dark matter seems to play the opposite role, pulling things inward, keeping galaxies and cosmic structures cohesive. The most curious thing: we can't see it, touch it, or detect it directly. Yet, we know it's there, making up about 27% of the entire universe. Scientists discovered the existence of dark matter by observing the movement of stars within galaxies. According to the laws of physics, the stars at the edges of a galaxy should move more slowly than those near the center, where there is more visible matter concentrated. But what they found was the opposite. The stars on the outskirts were moving just as fast as those in the center, as if there were an extra invisible mass, providing enough gravity to keep these stars in orbit. And that's how the dark matter hypothesis was born. It doesn't interact with light or any form of electromagnetic radiation, making it completely invisible. It's like a ghost that permeates the universe, undetected by our telescopes and traditional measuring instruments. But what exactly is dark matter? So far, we don't know for sure. Some scientists believe it's made up of exotic particles that have yet to be discovered. Others suggest that perhaps dark matter is a manifestation of physical laws we don't yet understand. Whatever it is, it's crucial to the universe's existence as we know it. Without dark matter, galaxies wouldn't be able to hold themselves together, and the universe would look very different. In fact, most of the matter in the cosmos is invisible. What we can see, like stars, planets, and nebulae, represents only 5% of everything that exists. The rest lies in the realm of the unknown, governed by forces we are only just beginning to understand.